Alright, let's get started with 3.5 matrix operations. The operations we're going to be using are adding and subtracting matrices and multiplying by a scalar. So a couple of vocab before we get started. A matrix is an arrangement of numbers in rows and columns. So here's an example of matrix A, and we have 2 rows and 2 columns. So the dimensions of this matrix is a 2 by 2, the number of rows and the number of columns. So the numbers in the matrix are called its elements. So the elements of this matrix are 1, 2, 3, and 2. So the first thing that we have to look for when we're adding or subtracting 2 matrices is if they have the same dimension. So the dimension of this first one, I have 2 rows and I have 2 columns. So the dimension would be 2 by 2. So this is a 2 by 2 matrix. Okay, and I want to add it to this matrix, and this one also has 2 rows and 2 columns. So this is a 2 by 2 matrix. And because they have the same dimension, we can add them. So the way we add matrices is we just add the elements that are in the corresponding position. So A and E are both in the top left. So my new matrix, top left, will be A plus E. Okay, now I can add B and F because they are both in the top right. So my new matrix will be B plus F in the top right. And I can do the same with the others, so I'd have C plus G, and I'd have G plus H. And for subtracting, we'll do the same thing. So again, I have a 2 by 2 subtracted by a 2 by 2. And so I'm going to take the corresponding elements and subtract them. So I'd have A minus E in the top left, B minus F in the top right, CG, and G minus H. Okay, here's one example for practice. So the directions say perform the indicated operation if possible. And it says if possible because if they are not the same dimensions, we cannot add or subtract them. So we have a 2 by 2 and a 2 by 2, so it's possible to add these. So our new matrix will be 3 plus -1. Then we'll have 0 plus 4 and -5 plus 2 and finally -1 plus 0. Okay, now I just simplify. So I'm going to get -3 minus 1 is 2. 0 plus 4, -5 plus 2, -3, and -1. So after I added my 2 matrices, this is my final answer. So let's try the bottom example. First of all, do they have the same dimensions? Well, this one is a 3 by 2, right, rows and columns, and this one is a 3 by 2. So my new matrix will also be a 3 by 2. Okay, I'm going to add the corresponding elements, so I have subtract. So I have 7 minus -2. 4 minus 5. 0 minus 3. -2 minus, I think that's a -10. -1 minus -3. and finally 6 minus 1. I encourage you to write out the steps inside the matrix and then simplify. Don't try to simplify. A lot more errors can happen that way. So now that I've written out the steps, I'm going to simplify it. So 7 minus a negative 2 would be 9. 4 minus 5 is negative 1. 0 minus 3, negative 3. Negative 2 minus a negative 10 would be 8. Negative 1 minus a negative 3 is 2. And 6 minus 1 is 5. So there's my final answer. Okay, matrix multiplication is the next operation we're going to look at. And a scalar is just a fancy word for a real number. It's often integers, sometimes it's fractions, but basically we use scalars to multiply a matrix by a number. So if I had this matrix and I wanted to multiply it by 5, the way we do scalar multiplication is we need to multiply every every element in the matrix by the scalar. So I would have 5 times A, 5 times B, 5C, and 5D, for example. So the directions say to multiply by a scalar if possible. Well, if possible doesn't necessarily apply to scalar multiplication because we can do scalar multiplication on any type or any dimension matrix. So we have a 3 by 2 matrix here. That means our answer will also be a 3 by 2. So basically we're going to distribute our negative 2 to each element. So we are going to have negative 2 times 4, negative 2 times negative 1, negative 2 times 1, negative 2 times 0, negative 2 times 2, and negative 2 undo times 7. Sorry, those are supposed to be negative signs, but they look like dots. So now I'm just going to simplify. Negative 2 times 4 is negative 8. And negative 2 times negative 1 is positive 2. And then I'd have negative 2 and 0, and negative 4 and negative 14 as my final answer. So this next example actually has 2 operations. We're multiplying by a scalar, which is 4, on the first matrix, and then we're adding that to the second matrix. So first what we need to do is the scalar multiplication. So I'd have 4 times negative 2, 4 times negative 8, 4 times 5, and 4 times 0. And I want to add that to my second matrix, which hasn't changed yet. And now we simplify. So I'm going to get negative 8 and negative 32, 20, and 0. Again, adding that to negative 3, 8, 6, and negative 5. Okay, before we add, we need to make sure that they have the same dimensions. So this is a 2 by 2, and this is a 2 by 2. So we can add. I'm going to get negative 8 plus negative 3, negative 32 plus 8, 20 plus 6, and 0 plus negative 5. And to simplify that, we get negative 11, negative 24, 26, and negative 5. as our final answer. So just remember, it's kind of like order of operations. You need to do the multiplication first and then the addition if you have two operations needing to be done on your matrices. Okay, here's an example problem I would like you to do, so pause the video and good luck. Okay, welcome back. Before we add these, make sure that they have the same dimensions. So we have a 2x3 and a 2x3. So we can add. If you add up the corresponding elements, we get -5, 6, 6, 2, -14, and 12. This is one I also want you to try on your own, so pause the video and good luck. So hopefully you recognize that this is a 3x2 and this is a 3x2, and that we can subtract them. So our answer will also be a 3x2, and we're going to get -6, -2, 10, -2, -8, and 15. So there are 6 elements to this matrix. This is also a 3x2. I want you to try this scalar multiplication, so pause the video and good luck. So after you perform scalar multiplication by -4, you should have gotten a 3x3, and it should be -8, 4, 12, 28, -24, -4, 8, 0, and 20. Okay, here's the last one. I would like you to try it on your own, so pause the video and good luck. So the first thing you should have done was the scalar multiplication by 3. So you should have gotten 12, -3, -9, and -15, plus the second matrix. And I hope that you can see that, like up here, this isn't -2 minus 2. Those are two separate elements. They're both a -2 and a -2. And so now we have a 2x2 and a 2x2, so we can go ahead and add them. Our answer will also be a 2x2, so we're going to get 10, -5, -9, and -9. Okay, that's the end of the video. Come to class tomorrow with your questions, and we'll go over a few more examples.